Okay, we're back. This is Professor Paul Gruhn from Manchester Community College. We continue our journey through Murach's MySQL book. We are on chapter 11 now, and we are going to really be pounding it and getting to work in this chapter. I'm not sure how long this video is going to be. I see 17 pages of tons of SQL that we need to work on and do. And this is the meat. We have played with existing databases, we've selected and joined and queried till our eyes have turned blue. Oh, mine already are blue. And we have done some database design. And from here, now that our database design work is done, we need to actually create some databases. And how do you start from scratch and build it? So that's the goal here. Also, for those of you who have been watching the videos for a while, just in this video here, video 11, I've made some changes. I'm using a different microphone. I'm curious if the quality of the audio is better than the other, and I've also done some lighting changes. So I'd be interested on the discussion board once you, so we're probably, once you get to this video, just to make a couple of comments if the audio is any better in this one to you, and if you think the video is any better. I've been fooling around with the lighting in my office and doing some things here to try to make the video just a little more quality and not so harsh in the lighting. Okay, let's turn to page, wow, do you believe that? We're in the 300s already. 313, read over the table of contents. If you haven't already, please pull up the PowerPoint and kind of go through the PowerPoint real quick, and then we'll just kind of pound it and see where this takes us. Okay, so we're going to pull up SQL Workbench again, and we're not going to go into our data modeling section because we've already got our models from what we've done in chapter 10. And we know where we go. Now we need to actually turn this into a reality. So let's click into SQL Developer and read page 314 and 315. It's got a bunch of SQL code for us to play and learn with. So what I'm going to do, here's the code that's listed on page 315. What I want to do is change the database from AP to AP2. So for chapter 11, I want to do everything in AP2 because what I want is, quite honestly, I don't want to mess up any of the data in the AP database that we've had. So we have a database server running MySQL. On my database server, and that's locally installed on your machine, on my database server, you can create many different databases. A database is a grouping of information on a given topic and subject. For your final, you will create a database on a single database. You won't need more than one. For your final project, your final business need will be that database. Within that database, you need to create tables, and those tables will have columns, and those columns and the IDs they'll have foreign and primary keys, and they'll relate to the other table so you can join and create views. Okay, we're going to create, as you can see in our schema browser, the database AP2 does not exist, but AP database does exist, and we've been playing with the AP database for a while. So I'm going to just create the AP2 database. I'm going to highlight this, whoops, first line. Just click on it using the single statement, and we can see that the command is executed separately. Come over to the object browser, and we do a refresh, and we see AP2 databases there. If we open this up, we see tables, views, and routines, but when we click on each of those, they don't exist. There's no tables, there's no views, there's no routines for the AP2 database. Another way to, so now let's issue that command again. If I created the AP2 database, if I issued this command again and it already exists, what happens? We get this error here, can't create AP2 database, it already exists. Now we have another version of the same command, create database if not exist. So I'm going to run that. And it says, warning, can't create the database because database 2 exists. And it's a little softer warning this time. And it's saying, hey, listen, I checked, it does exist, so I'm not creating you. Now we can drop a database. Drop it, and we did this in an earlier chapter where we got rid of, I think we got rid of a table. We actually dropped a table. Here we can drop a whole database. So I can issue the drop database. I'm going to come back here, drop AP2, I'm going to refresh, and we see AP2 doesn't exist. I'm going to now issue drop database if it exists. So I'm going to, and then here we get a soft warning, can't drop the database, it doesn't exist. And if I try to use the AP2 database, it says unknown database AP2. So let's go back up to one of these two creates, doesn't matter which one, and issue it. And we see one row affected, and it was created. Refresh our object browser, AP2 exists. Okay, let's move on. Okay, now that I've flipped over to page 316 and 317, I'm seeing what the book's doing here. And you remember a while back that there were some tables in the AP database and some tables in the EX database, and we kind of needed each one of those. Well, what's happened is there's a few tables that have not been created, like the vendors table and the invoice table in this EX database. And the EX stands for examples. And so what we're going to do is the last thing we said was to use AP2. Well, we've learned we can create a database. All the commands we're issuing now, we can create our own databases with and create tables with, etc. So, for instance, if you're going to create a Corvettes database, you might, create a database called Corvettes. So while I'm doing that, while I'm thinking about that, I just want to have that in my hip pocket because we'll see where I go with that. Create Corvettes. Now I'll refresh the object browser, and I now have a Corvettes database. Nothing's in it, but it's there ready for me to go. Okay, what I want to do now to get back in line with the book on page 317 is I want to use the EX, the examples database. Now, and we see that I created my Corvettes database down below, and I'm using now the EX database so we can issue these create table commands. In page 317, the vendors table does not exist, and the invoices table does not exist. Now what's interesting is it gives us two create statements for the vendors table, and let's look at the difference of these. So we said use EX, and I'm going to create a vendors table, and I want the vendor ID to be an integer type, and I want the vendor name to be a varchar. And if I highlight this and I run it, I'll see that the table got created. I refresh the object browser, and I see the vendors table now exists, and that there's two columns in here. What I want to do real quick is I want to drop drop vendors. I think it's not the command. Drop table. Refresh. Vendors is now gone. Now we're issuing these commands in the SQL editor, and we're actually writing code to do the work. If I wanted to, I could take on this tables in the object browser, right click, and I could go create table. And I now have a GUI in which I can write vendors, and I can then go, I can add a column, vendor ID. I can make it an integer, and I can make it a primary key and not null, and click apply. And then what's interesting is, see what happens is, it actually created the SQL script that we are going to be typing. And then I can click apply. And I can say, go ahead and issue it. Or I can say, nah, don't issue it yet. But I'm going to issue it. And then if I come over here, here's my vendors table, my columns, and I've got my vendor ID already. So while this book is focusing on us writing code and knowing the code to create these tables, the MySQL Workbench has the ability to do everything through an IDE, a user interface. And so you could not worry about all the commands on. But the problem is, if you do it this way through the GUI, that you don't learn the code that's behind the scenes. And when you get into CSC230, the PHP and MySQL class, you're not going to have any GUI. Everything's going to be code driven, and you're going to need to understand the code that you're doing. So we're not going to focus on the the GUI part of creating the keys and the indexes. We're going to focus on using the code. Another way I could drop this table, by the way, is right-click on it, and I could go drop table. And notice, it's showing the code that it has to run. Click apply, click finish, and then I come back here, my vendors table is gone. Now, you remember just now in the GUI, what we did was we said not null and unique key, and we also want that vendor ID to be auto-incremented. So we first issued this command, which just gave us the columns, but it didn't give us any of the characteristics to each column and field that we actually needed. So this is the actual true statement. Create table called vendors, parentheses, vendor ID, it's got to be an integer, not null, unique. In other words, it's got to be a primary key, unique, and I want you to set it where it will auto-increment, and then we have a comma, because the next column is vendor name, it's going to be varchar, not null, unique, and then if we had another column, we'd go put a comma there, and then type in, next column name. So let's issue this command. Refresh. Vendors is here. Vendors columns are here. And what's nice is as I highlight the vendor ID, I see that it's an integer, primary key, auto increment. If I highlight the vendor name, I see that the vendor name is a varchar 50. Okay, let's move on. The other table that doesn't exist is the invoices table. We don't see the invoices table in the examples database. We do see the invoices table in the original AP database. So in the examples database, we need to add it, and it's given us the SQL code on page 317. Invoice ID, vendor ID, invoice number, invoice date, invoice total, payment total. We see that the various data types are listed, a varchar, a date field, and a decimal field. We see which ones have to have data in it and which ones are unique. And here the payment total has a default of 0. So I can just click anywhere on that. What I do need is a semicolon. Click anywhere on that, or highlight it and execute that command, and come down here, refresh. We see our invoices table is here, and all of the various fields are there, and we can even notice, here the invoice ID as a primary key. What's interesting, payment total, it doesn't tell us in the object that it's actually default 0. On the information. I'm surprised by that. Okay, let's flip the page over to 318. Okay, in an earlier chapter, we talked about database integrity. And what we want to do is we want to program in the database integrity and the referential integrity from one field to the other and one column to the other into the design when we actually create our databases. Now, we've created the vendors table already, But on page 319, it shows us a couple of more ways of creating the database with some indexes and some constraints on it that are going to force the database, the data table, to be smart enough to know you can't do this. I'm going to throw an error if you try to do this because you're breaking one of my rules. Okay, so the first thing we need to do is, because we're going to build the vendors table again, we already have a vendors table, but the referential integrity is not strong enough, and we want to add some quality to the database itself, the data table itself. So let's drop the vendors table, drop table vendors. And then here, just like we did on the invoices table, we can create it with a primary key, auto-incrementing, and the vendor name, not null, unique. Issue that. Now we've added those referential integrity qualities to those column names to make sure that things aren't null, that there is a primary key, it auto increments. But that's not enough. So we're going to drop the table again. And it's going to say, hey, I want to add constraints on a primary key called vendor ID. I want to also create constraints on the vendor name to make sure it's unique. Let's run that. Okay, so now we actually have a better quality vendors table. And we have some stronger rules and constraints on that. If you remember correctly, we also had an invoice line items table in our AP database, and we're wanting to create that table as well. So there we go. So all these tables now exist. I'm going to refresh, and here's invoice line items, and there's the columns: invoice ID, invoice sequence, item description. So we have our tables created, and let's go on from here. Okay, page 320 and 321 go into more detail about foreign key and foreign key constraints. And we're still in the EX database. Use that. And we're going to drop table invoices. And we're going to follow on page 321, excuse me, create invoices. We've created the invoices key. We have a primary key. We have a reference with the vendor ID for the vendors, and we have a not null unique for the invoice number. But that's not enough. What we need to do is, because this invoice table is going to be tying to the invoice line table with some foreign key constraints, I'm going to drop the invoices table, and you will see a stronger version where we're adding constraints for the foreign key of vendors in referencing the vendors table based upon the vendor ID. So as you think about the relationships between your primary table and your secondary table and the primary key and foreign key, do you want errors to be thrown by the database if somebody tries to delete something that doesn't exist or does exist in another table that would break the relationships? And this is where you need to add these foreign key constraints. So in other words, if I was trying to add a record into invoices and say the vendor number didn't exist, I need to throw an error and say, hey, listen, I can't relate to any vendors because vendor number 20 doesn't exist. Okay, so as you've noticed that what we've been doing the last couple of minutes for each individual table is when we wanted to recreate it or make changes, we've been dropping the table first and then building it again. Now let's say you have tons of data, tons of orders, tons of vendors, tons of information in there. But what you really want to do is not lose your data. You don't want to drop your table because everything goes bye-bye. And remember earlier we talked about creating a table and making a copy of a table. So before you start messing around with tables, go back to that create table command from the other table and create a backup copy. And even before you do these upcoming commands here on page 322 and 323, if you have data you don't want to lose, I highly recommend that what you do is make a copy of your data table, and then from there, issue your commands on that copy. See if it works and does what you want. And then make another backup, and then issue it to the main table. Okay, on page 322 and 323, we're going to be working with the vendors table that we created in our example EX database. Let's describe the vendors table. And right now, there's not much in it. There's a vendor ID and a vendor name. Primary key, and we have a unique key, and it's auto-incrementing. But say if what we need is to add some columns. So here's an example, and it's actually, one full statement where it says, alter the table vendors, adding last transaction date column, and make it a date type. So if I issue that command, it was successful. And if I describe the vendors, now you see that that column is there. What if I don't want that column? Well, there's just like this drop database, drop table, you can even drop a column. I'm going to drop the last transaction date, describe vendors, it's gone. Let's put that one back. I want to add it. And now we have alter table vendors, modify the vendor name to be varchar 100. Let's take a look at the described vendors. Notice that varchar is, the vendor name is 50 right now. So we need it to be longer. We decided that there were company names that actually had longer. So let's highlight that. Click on that, run that, describe vendors, and we see that the vendor name is 100. Vendor name, it can't be null, and we want to default to always say new vendor when that record's created, just in case we don't have a vendor name. So we're going to alter that. And maybe we want to say vendor name, varchar, not null, and unique. And we want to alter that. So there's a lot of, let's go back and describe. I actually want to go back and I want to do this one here. Yeah, matter of fact, here's vendor name, and you can see new vendor is the default on it. And here we're vendor name, and we modified it to 10. Varchar, let's see, let's issue this again. And describe. And it moved it to 10. Quite honestly, 10 is not enough. 100 might be too much because of address labels of the past, but let's keep it at 100. And describe. And we're good at 100. Excellent. So you get the feel that if you can do it for one column and do modifications of a column, you can do it for any other column. You can add columns, create new columns. So here what we were doing is we were adding a new column, and down here we were modifying existing columns. Okay, pages 324 and 325. Quite honestly, I'm getting kind of bored now, but it's actually important because we're talking more about altering the table and some more specifics dealing with adding a primary key, adding a constraint on a foreign key, dropping the primary key, and even dropping the foreign key. And so just issue these commands that are on 325, I guess. Yep, 325. And you'll see the syntax for those. Altering table, and we get an error here, multiple primary keys defined. So it doesn't like that, the fact that that already exists. Alter, is it going to throw an error there? See, it's throwing errors on the fact that these already exist. Let's drop the primary key. It doesn't like that. And alter the primary key here. It actually liked that one there where it did a drop. So now will it let me actually add the constraint and create this one this time around? Let's see. And it actually liked it the second time around. So you actually had to drop the foreign key reference, and you had to drop the primary key before you could add the key to actually get the constraint to be kicked in. So stuff's important in the sense of the relationships between the primary key and foreign key. Most of the time, quite honestly, if you've designed your database up front, you've just done it and it's worked. Unless maybe down the road you've added a column, and that column needs to be a foreign key to another table to get some sort of references to. Okay, so we've already used these commands listed on page 326 and 327. Truncate table, table name, that basically will delete all the data that's in the table, but not drop the table. Dropping the table actually removes the table. And notice here, this first line is dropping the table, assuming you're in the EX database. Here, we're dropping the table that's in the EX database. Drop table vendors. And the one command that we haven't done yet is rename table vendors to vendor. And it does exactly what it says. Okay, so indexes are used to help MySQL find the data quickly when you're doing your select statements. And so you'll have the data in a column, and so it doesn't do a full table scan, go through every single row, when an index will actually help get the data that you want more quickly. And the syntax is actually pretty straightforward. We're on page 328 and 329. Basically, create an index called Invoices Index Date IX for index on the Invoices table based on the invoice date. Here it is, create invoices vendor ID invoice number IX, and this is on the invoices table based upon putting the vendor ID and then the invoice number right next to each other. Here's one for the phone number if I want to get a quick look up on the phone number. Here's one on the invoice total, but it's done in descending order. And here's dropping an index, drop index, vendors, vendor phone, IX on vendors. Most of the, excuse me, most of the tables that we're working with, quite honestly, are so small at this point that indexes aren't needed, but they are needed on your keys. And so on your key tables, when you have a relationship between a primary key, a foreign key of one table to the primary key of another table, always have that primary key indexed. And basically just issuing these commands, I issued the first one, issuing the next one, issuing the next one, and issuing the next one. And now if we take a look, and if I go to vendors, if I take a look here at indexes, that actually if I take a look at the under tables, under the vendors table, I now see that I have a primary key index and I have a vendor name index created. Under the invoices table, I see I have indexes here, one based on the invoice ID. Okay, so what if you remember, the very, very first assignment you had to do in this class was to install MySQL Workbench, MySQL, and you actually ran a script which created the AP database, the EX database, and the OM database. We've learned a lot of commands so far, and we've learned them individually. Do this, do this, do this, do this. You can put all of those commands together into one script that it will do all the different things all in once. So for your final project, one of the things that you're going to have to do is create a script very, very similar to this one. And I would take a look and I would save page 331. I would highlight it, I would star it, I would put a bookmark, a sticky note or something on page 331, because this is the model that you will need to create for your final project, is to create a database script that will create your final project tables. Now, what I'm going to do here is I'm going to change the name of the database to AP3, AP3, AP3. I'm going, and the script starts off with, and remember, the goal of this script is to create a database from scratch. So the first thing I want to do is drop the database if it's there. I want to get rid of the old one. So if AP3 exists, get rid of it. I want to create it, and then I want to use it. From there, I want to create the general ledger table. I want to create the terms table, the vendors table, the invoices table, the invoice line item table, and then I also want to create an index. So I've got one file that does it all. And then also what I want to do later on, once the tables are created, I'm going to want to do a bunch of insert statements to insert in the base information for this data. So all I have to do is just highlight everything, and I probably actually don't even need to highlight it, but Control A, and then if I just run this, execute it, and it's all run, I refresh my objects. Now take a look. I have AP3. I have all the tables created. I take a look at terms, and I see that I open up terms. I have the columns, terms ID, terms description, due date. So basically, page 331, 330, and 331 are the sum total of everything you've learned in this chapter on how to create the databases and the tables, and what they've done is added all the other fields that you need. So now go back to your chapter 10 assignment for the final project and think about and map out the type of create statements that you will need for your database, because guess what? That's one of your homework assignments for chapter 11. Okay, so I'm going to call it a day for chapter 11. You have about 15 more pages. Some of the pages go into a little more detail for creating some more tables for the AP database. If you're going to run them, I'd do it for the AP3. Gets into a little bit of MySQL Workbench, and there's some interesting information there. Read through that, go over it. And then it gets into some esoteric things with character sets and some system variable names. All very interesting stuff. You'll use some of it, but it's not the primary focus of stuff that you'll need on a day-to-day basis. You probably, for the next 10 pages, got a half an hour, maybe 45 minutes worth of read and look through. Say a half an hour, and you'll be able to get through it pretty quickly. But you definitely have enough to do the homework assignments in chapter 11 and the additional homework assignment for your final project, which will be actually to create a script and run it based upon your description, your EER, your expanded entity relationship diagram that you've already created for your final project. The goal of a lot of the upcoming assignments the next couple of weeks will basically be you're doing your final project early. So instead of just saying at the last week, here, do your final project, you're working towards it now. And it's okay to make changes along the way. I expect that the EER diagram that you made last week, or actually this week, yeah, last week, that it's not perfect, and you'll need to change it. You'll want to add things to it. And the script that you're making today for your final project, next week you can say, I want a different table, or I want a different column. That's okay. Do not consider these final project assignments to be the end game. These final project assignments are preparing you to then create your final project. So I hope you're having fun. We're already up to 335, 340, 345 it looks like, even a little further than that. So we're really whipping through this book. We only got a couple hundred pages left, so piece of cake.